Here, your first question is 30% of the residents of Wimfield own an electric car. 3 residents are chosen at random. Find the probability that either all 3 own an electric car or none of them own an electric car. Now, if you see here, this is a problem of binomial distribution. Now, if I consider this as a problem of binomial distribution, then here possibility of success, that is possibility of owning an electric car, is 0.3, and possibility of not owning an electric car is 1 minus 0.3, which is 0.7. Now you have chosen 3 residents, so here n is equals to 3, and we will say that x follows a binomial distribution with n as 3 and possibility of success is 0.3. Now here your problem is find the probability that either all 3 own the electric car. So here our probability is probability of x is equal to 3 or x is equal to 0. All 3 own an electric car or none of them own an electric car. X represent the number of residents owning an electric car. So this will be equal to probability of x equal to 3 plus probability of x is equal to 0. Now when I say probability of x equal to 3, it will be 3c3. Your possibility of success, which is 0.3, so 0.3 power 3, and possibility of failure, which is 0.7, 0.7 power 0. Plus, when none of them are owning the electric car, then in that case your possibility is 3c0, 0.3 power 0, 0.7 power 3. Okay, so here we are using the formula probability of x is equal to r is equals to ncr p power r q power n minus r. So this will give you 0.3 cube plus 0.7 cube. Now let us see what is 0.3 cube. So 0.3 cube plus 0.7 cube. Here the result is 0.37. Here the result is 0.37. Now B part of the question, a random sample of 125 of the residents of Wimfield is selected. Use the suitable approximation to find the probability that more than 45 of these residents own an electric car. Now here n is 125. It is a large number, more than 50. Your possibility of success is 0.3, which is close to 0.5, I will say. Now NP is 125 into 0.3. Now when your n is large and the possibility of success is near to 0.5, then in that case the binomial distribution is approximated as normal distribution with mean. Here mean is 37.5. This is your mean, and your variance sigma square is NPQ. So NPQ is 125 into 0.3 into 0.7. So this result we will multiply by 0.7, and here the result is 26.25. Result is 26.25. This is your NPQ. So therefore we will say that X follows a normal distribution with mean as 37.5 and variance as 26.25, and we have to find out the possibility of X more than 45. So x greater than 45. Now binomial distribution, we are approximating to normal distribution. So we will use the continuity correction. And I will say that possibility of x greater than 45 will become possibility of z more than 45.5. Now 45 I do not want to include, so in continuity correction I will use 45.5 minus mean is 37.5 divided by standard deviation is square root of 26.25. That is, I have to find out possibility of z more than, now here 45.5 minus 37.5 whole divided by square root of 26.25. So the result is 1.561. Z greater than 1.561. Okay, now let us look at the normal table. We have to check for, here we have to check for 1.561, z greater than 1.561. So this is equal to 1 minus pi of 1.561. Okay, if you see your normal table, here I need to find out possibility of z more than this 1.561. So this area I need to find out, which is nothing but 1 minus this left hand side area. So this is 1 minus, now 1.561, 1.5 is here, 6 is this value, and 1 is this value. So 0.9407. 0.9407, that will be 0.0593. 0.0593 is your required possibility. So this problem, if you see, it include two part. Your part 1 is purely a binomial distribution, and part 2 is your approximation of binomial distribution to normal distribution.